Hi everyone, welcome back to my channel. Today we'll work with, Python and we'll try to solve a transportation problem using Seaborn. So let's exactly talk what this script do. So it's create a small reproducible transportation dataset using NumPy and Pandas. So we'll like to create data by ourselves. Then supplier with capacity, customers with the requirements, so demand and supply. Then cost matrix, cost to ship from each supplier to each customer, and simple visible shipping plan location for demo plots. Then we'll build multiply Seaborn charts to help explain transportation problems, the issue that we usually have. So supply and demand bars, sanity check of totals, cost heat map, where shipping is expensive, cheap, allocation heat maps, where we actually send goods, stacked bars, flow by region and destination, and unit cost versus shipped scatters. Are we using low cost lines? And why we are visualizing like this? Because stakeholders quickly see what supply match demand, which lines are costless, and how the location uses or avoids those lines in practice. Great for before-after comparison when testing optimizer or policy chains in your transportation departments. Our requirements, so what drivers we'll use is Pandas, NumPy, Matplotlib, and Seaborn. Let's jump to the code. In code we start as usual with the import, so import NumPy as NP, Pandas as PD, Seaborn as SNS, and Matplotlib pyplot as PLT. Global style, so we'd like to have the same style with clean presentation rich style, so as SNEs, Seaborn, set teams, and then avoiding label clipping. Let's create synthetic data creation, so we're using NumPy, supplier customer, which you can see here, then create supply and demand that roughly balance, so with Pandas series. Then let's adjust the ensure total supply is equal to total demand for the tidy demo. So we say total supply is equal to supply sum, and the same for the demand. And there we have the if statement, so scale demand to match total supply, and tiny fix rounding drifted us for a few units, right? So assert we should be sure that the totals for demand and supply match for this demo. Then let's build a unit cost matrix, and lower level is cheap, upper right is expensive, so to add some noise for the variation, increasing across customers and slightly presence for the suppliers. Then we create this data frame, so called data frame is equal to Pandas data frame in what we already create, so all of this creation above. Then step number 2 is simple visible location, not optimal just for the plotting, and grid fill if which suppliers ship to cheapest customer first. So what we can see here is allocation, then PD data frame, remaining supply, remaining demand, and we have the for loop and sanity check. So all supply should be allocated, all demand should be met. Then tidy long tables for plotting. So try to make the plotting data. So keep only used lines, first step, and add using cost all total line scores for analytic scatter plotting. And the most important part, so the plotting, so what we exactly will be doing. So step number A. Step A, supply versus demand, cook, balance, and check. So then figure and X type PLT subplot, so using plotlib, then CATP plot PD data frame, and we'll plot supply and demand separately to label clearly. So you have Seaborn, and then bar plot, and then set title, set label, set EY label, and the spine to just present the data. Then the B, unit cost heat map, which lines are cheap versus expensive. We'll just change the option that we have. So we're using Seaborn, but then we're using the heat map. So the other function. Then the allocation heat map where we actually send the volume. So we're still using the heat map, but different column are plotting there. D1 stacked bars outbound for each supplier. And then the 2 stacked bars inbound to each suppliers. Then we are jumping to unit cost versus shipped, our allocation to low cost line using the scatter plot, and then the metrics table. So what we will be exactly plotting. So total cost is allocation multiplied by cost data frame to NumPy sum to have just the numeric value. Then we have a lot of printing. So we have print. You can see here quick metrics, then the total supply, total transportation, allocation tables, and we can jump to visualization. So first we create the supplier by supplier, then demand by supplier, our first heat map, so customer, unit shipping cost per unit of course, then allocations, units shipped, customer, outbound mixed by shipped, suppliers mixed by customer stacked. The last thing was the scatter plot. So scatter we can see shipped volume versus units by line, so you can see the suppliers and the customers with unit cost. Okay, that should be it for this video. Thank you for watching.